Bismillahirrahmanirrahim. Dear students, good morning. Today is our second lecture in organic chemistry, and this lecture is about the nature of covalent bonding, part 2. As we already discussed in the first lecture about the atomic structure, different atomic models, atomic orbitals, molecular orbitals, and the electronic configuration according to certain rules. In this lecture, we will discuss about the following topics: the octet rules, the Lewis structure, formal charge, and the breakdown of the octet rule, which lead to the concept of the resonance. So, first of all, I want to briefly explain about the periodic table, because we should know about the periodic table in order to explain the bonding nature. So periodic table is, you already aware of it, that is the table of elements which is in which the elements are arranged according to the increasing atomic number, according to the Mole's periodic law. So in periodic table there are two things. One is the groups and the other one is the periods. So the period is the horizontal arrangement of elements, while the groups are the vertical arrangement of elements. In groups we have two kinds. One is we say group A groups, and the other one we say B groups. So our concern is about A groups, which we also always says normal groups. So there are 8 normal groups. So we are not discussing the transition elements, the D block elements and the F block elements. So this is the first group, alkali metals, and this is the first group because there is one valence electron in the outermost shell of this of these elements. The second groups, alkaline earth metals, the boron family, carbon family, nitrogen and phosphorus family, oxygen and sulfur family, halogens, and the noble gases. Okay, so first of all, we can say that atom, because not all of the atoms have complete octet except doublet for the helium. So every atom wants to attain the stable electronic configuration of the noble gases, and for that purpose elements always form bonds. So the concept of the chemical bond, and the concept of the chemical bond this was first introduced, we can say the covalent and ionic bond was first introduced by G.N. Lewis, an American physical chemist, born in 1875 and died in 1946. So G.N. Lewis is one of the famous scientists which has a greater contribution in the physical chemistry, which also explain the covalent bond, the dot structure, which we also says the Lewis structure, which also who also explain the concept of the acids and bases. So Lewis is one of the important and famous scientists, but unfortunately he was not awarded a Nobel Prize. Although he was nominated 41 times for the Nobel Prize, but due to some clash with a German physicist, he was unable to attain the Nobel Prize in chemistry. And Lewis also died. Also, the death of the Lewis is also controversial, and someone says that he suicides. Another scientist which is also very important, and that one is the German physicist Walter Kossel. So Walter Kossel has also a greater contribution in the field of chemical bonding, ionic bonding, bonding and octet rules. So now we are going to discuss about octet rules. What is octet? Octet means 8. So according to this, the tendency of an atom, the tendency of an atom to have eight electrons in the valence shell. So when an atom have eight electrons in their valence shell, then we says that this atom obey octet rules. Okay, so according to the Lewis and Kossel, we can explain the covalent bonding and ionic bonding on the basis of the octet rules. And we can say that covalent bonding is actually, you already aware of this, the covalent bond is two electron bonds. And covalent bond always formed by the mutual sharing of two electrons. So for one covalent bond, per single covalent bond, we should have at least two electrons. Similarly, we can explain the molecule on the basis of, so there are also difference between the molecule and we can say the ionic compound. So ionic compound always ionic bonding, while molecule is the compound of the covalent bond. Compound of covalent bond. Now, there is a question that how many covalent bond each atom can form. How many covalent bond each atom, how many covalent bond each atom can form. So this will depend upon the valence electron of an atom. And you see that according to the periodic table, if we take the example of the hydrogen, so how many valence electrons are there in hydrogen? So there is only one. It means that hydrogen can form one covalent bond. When two hydrogen combine with one electron each, so we can get hydrogen single covalent bond. Similarly, if we take the example of carbon in the fourth group, so because you know that carbon has 4 valence electrons, so carbon can form 4 covalent bonds. We can also take the example of fluorine. So, but we will discuss this, that why fluorine, because it has 7 electrons in their valence, but fluorine can form only one covalent bond. So it means that the number of covalent bond is always equal to the number of valence electron. Okay. As I already tell you that hydrogen can form one covalent bond, boron can form 3 covalent bonds, carbon can form 4 covalent bonds. But atom with atomic number 5 or atom with the valence electron 5 or more, how we can calculate the number of covalent bonds for the atoms? With valence electrons 5 or more than 5. So the number of covalent bonds predicted, which we can predict, can be predicted on the basis of 8 minus valence electron. 8 minus valence electron. For example, for nitrogen, we can say there are 5 valence electrons, so we have 3. It means that nitrogen can form 3 covalent bonds. For oxygen, we have 6 valence electrons because oxygen is present in the group 6. So we have 2 covalent bonds. Similarly, for halogens, you can say 8 minus 7, which can form only 1 covalent bond. As I already told you, that fluorine, although contains 7 electrons in their valence shell, but it can only form 1 covalent bond. And you know the noble gases. So for noble gases, 8 minus 8, it means there is no possibility of covalent bonding in noble gases, although let us research show that noble gases also form bonding. Okay, there is a question which answer you can give, that how many covalent bond produced by boron. So you can answer this. Okay, now there is a question that for the second row elements of the periodic table with more than 4 valence electrons cannot form more than 4 covalent bonds. There is a question. For elements of row, we can say of second row, means second period, with more than 4 valence electron cannot produce more than 4 covalent bond. We already discussed it. For example, if we take the example of hydrogen, if we take the example of carbon, if we take the example of the nitrogen, if we take the example of oxygen, and if we take the example of halogens. So you see here the bonding electron for this 1 bonding electron, for hydrogen is 1, for carbon is 4, for nitrogen is 3, for oxygen is 2, and for the halogens is 1. But there is some other electrons which we can say the non-bonding electrons. So for the hydrogen there are 0, for carbon there are 0, for nitrogen we have 1, for oxygen we have 2, and for the halogens we have 3. So it means that hydrogen can form only 1 covalent bond with no non-bonding electron. Carbon can form 4 covalent bond with 0 with no non-bonding electron. Nitrogen can form 3 covalent bond with 1 non-bonding electron pair. And similarly, oxygen 2 and the halogens has 3. Okay, you can predict about the non-bonding electron of iodine according to the electronic configuration. So this question, how many non-bonding, you can say lone pair electrons are in iodine? Okay. Now we will discuss about the Lewis structure. Lewis structure. How we can draw a Lewis structure for a molecule. So there are certain important steps which you should know about the Lewis structure. So the first step is drawing of skeleton. Drawing of skeleton. So how we can draw a skeleton for a molecule? For example, if someone says that draw this Lewis structure for methane, CH4. So how we will draw the skeleton of the methane or any other molecule? For this purpose, we have some certain rules. For example, hydrogen will be always on the one end of the molecule. Fluorine especially will be on the another end of the molecule. So hydrogen and fluorine cannot be put in the middle of the molecule. So which element can be put in the middle of the molecule? So this will be decided on the basis of the electronegativity. The least electronegative atom should be put in the middle of the molecule. So for example, if we take the example of the methane, so in methane we have two kinds of elements. One is carbon and the other one is hydrogen. So in this case we will put carbon in the middle and 4 hydrogens at the ends or at the corners. So the first step is about the drawing of the skeleton. So you should know about which element should be put in which point or in which place. The second step, to find out the valence electron, to calculate the valence electron. Calculation of valence electrons. And you are already aware of this. For example, there are one valence electron with hydrogen, and we have 4 hydrogens, so we will get 4 valence electrons for all 4 hydrogens. Similarly, we have 4 valence electrons for the carbon. So the total number of valence electrons are 8. But there is one point in this step. If we have a charged molecule, for example, if we have a molecule with positive charge, for example, if we have H3O plus 1, then we should subtract 1 electron from the valence. So we will write here like valence electron minus 1. So if we have a molecule with 2 positive charges, then minus 2, 3 positive charges, minus 3. In case of the negative charge, for example, if we take the example of the cyanide, minus 1, then we will add one electron with the valence. The second step is about the octet electron. The third step, calculation of octet electron. Octet electron you already know, which make the complete shell of an atom. So per hydrogen we have 2 octet electrons, so 4 into 2 plus 8. So the total number of the octet electron are 60. Now step number 4 is about the bonding electrons. So calculation of the bonding electrons. So how we can calculate bonding electrons? Octet electrons minus valence electron. Octet electrons minus valence electron. So there are 16 octet electrons and 8 valence electrons. So we have 8 bonding electrons. We have 8 bonding electrons. Now we will assign, in the next step we will assign 2 electrons for each covalent, single covalent bond. So step number 5, assign 2 electrons for each covalent bond. So we have 8 bonding electrons. So we will there are 8. So we have 4 covalent bonds. Another step, if we have 4 bonds and we have more than 8 electrons, then there is possibility of a double bond or triple bond. And you know that. So step number 6, what will we do with the extra electrons, extra bonding electrons. So that bonding electron, extra bonding electron will be used for double bond. For example, carbon can form double bond, nitrogen can form double bond, oxygen can form double bond, sulfur can form double bond, as well as for triple covalent bond. So only carbon and nitrogen can form triple covalent bond. Step number 7, calculation of non-bonding electron, which we can say lone pair of electron. Lone pair of electrons. Okay. So for this, we will subtract valence electron and bonding electron. So how many valence electrons are there in this molecule? So we have 8. And how many bonding electrons are there? So we have 8. It means there is no bonding electron in this molecule. No non-bonding electron in this molecule, or we can say no lone pair of electron in this molecule. Okay, let's try some other examples according to these rules, and you can practice it. Okay, so we can take the examples. For example, we can take H2O. Another example is CH3F. So the first step is drying of the skeleton. So you know that oxygen and hydrogen. So we will take oxygen in the middle, and both hydrogen on both corners. In this situation, we have three different kind of elements: carbon, hydrogen, and fluorine. So you already know that hydrogen and fluorine must be put at the corners. So we have only one choice, that carbon will be put in the middle of the molecule. So this one is the first step. I am not writing it now in detail. In the second step, valence electrons. So how many valence electrons are there? 2 into 1 plus 6. That means 8 valence electrons. How many valence electrons are there? 3 into 1 plus 4 plus 7. And we are not subtracting nor adding any value in these molecules, because there is no positive or negative charge on the molecule. So in this situation, we have 14 valence electrons. The third step is the octet electrons. So how many octet electrons? So 2 plus 8, and we have 12 octet electrons. Here 3 into 2 plus 8 plus 8. So we have 22 octet electrons. Now the fourth step is the bonding electron. So we already know that bonding electron is always the octet electron minus the valence electron. So we have only 4 bonding electrons in the molecule of water. And there is 22 minus 14. So we have 8 bonding electrons. Okay, the next step is assign 2 electrons for each covalent bond. So we have 4 electrons, so we will assign 2 electrons for this covalent bond and 2 electrons for this covalent bond. Similarly, in this situation, we have 2 electrons here, 2 electrons here, 2 electrons here, and 2 electrons here. And because all of the electrons are used in the single covalent bond, we have no extra electron. So we will skip the sixth step. So the fifth step is assignment of the electrons. The sixth step is the usage of the extra electron for the double and triple covalent bonds. And the seventh step is the calculation of the non-bonding electron, and we can say the lone pair of electrons. So now in this situation, how many lone pair of electron are there? You can say valence electron minus bonding electron. So we have only 4. So you can assign these 4 electrons to oxygen. Okay. Now in this situation, we have 14 valence electron and 8 bonding electrons. So how many lone pairs are there? You can say 6. So we will put these 6 lone pair of electrons on fluorine. So this is all about the Lewis structure, and you can practice it with many molecules. Maybe we will discuss some molecule later on, but you can try, you can practice. And then a question: which element should be in the middle of? Which element should be in the middle of CH3Cl? So you can answer. Okay, this is all about the Lewis structure. There is one and many others Lewis structure. For example, sulfuric acid, and we can say chromic acids, or many others. which is not according to the Lewis, and we will discuss it later on that how the octet rule breakdown takes place. So the third topic is the formal charge. Generally represented by FC. So what is formal charge? So formal charge is actually the charge assigned to an individual atom in a molecule, or we can say in a Lewis structure. The charge assigned to an individual atom in a molecule. You can say Lewis structure. So this is the definition of the formal charge. And there are some importance of the formal charge. So we will discuss this later on, that we can predict about the best structure. If we have a choices of structures and we have to decide which structure is the best, so we can decide on the basis of the formal charge. And similarly, we can also decide the stability of the structure.